choose P1S. And then I'm going to define that ratio as alpha here, so let me just write it and then talk about it a little bit. So alpha 2,1, which for a Raoult's law system, well, first of all, it's called the relative volatility. Of 2 to 1. And for our case, it is just the ratio of the vapor pressures. System's not obeying Raoult's law, it's a little bit more complicated, but this is what it is for this case. And you can just look at here, the vapor pressures depend roughly in the same way on temperature, so I expect that to be a very slow moving function with temperature. And that makes this iteration scheme useful. I will iterate on the vapor pressure here of component 1. So I'll rewrite this equation explicit for P1S. This way. So now I'm set to iterate on this quantity, and I can set up the iteration as follows. So to start out by choosing an initial temperature. And it turns out it's not going to be very sensitive to this, but this is usually the mole fraction average of the temperature and the temperature for the phases of known composition. So we can set that equal to the mole fraction average saturation temperatures. So we would say that's going to be T0. We'll take that as 0.6 times T1S plus 0.4 T2S. And these are, get those out of the respective Antoine equations. So let me write that out. See, enough time to do this? Yeah, we're not going to be able to finish this. TS is a similar expression. This works out to be 81.1 degrees C. This one works out to be 101.1 degrees C. So we take this average, it's going to be 89.1. So that gets us started. And I barely have enough room here. Enough. So the way the iteration goes is that we start with that temperature. Step 1, we'll calculate alpha 2,1. Then out of that alpha 2,1, we go back here, and step 2, calculate P1S. And then from that P1S, we invert it and calculate a new temperature, and then we go back and iterate back. Well, obviously I'm going to have to go over this again. And I think what I'll do, we'll probably have time, there's no quiz Friday, so we'll probably have a little bit of time when we'll finish going over the homework. If not, we'll wait till Monday, but I may have time to finish this iteration procedure for you